And they've got a life example of using arithmetic sequences to predict something. Certain comets that fly through our galaxy, I don't know if you're a comet watcher, if you like to look at the stars, they happen periodically, and this particular comet appears every 9 years, right? So for some people, that's like every 9 years there's a tiny little streak that goes through the sky. Some people say that's not that exciting because all it is really a little white dot moving through the sky. But other people see it as this is a huge thing traveling through the universe, and when they think of it on that scale, that's pretty amazing. And the fact that it only happens every 9 years, taking that all in, then it becomes pretty amazing. So I guess it's all on your perspective. Actually watching it, little tiny white dot. Thinking about the big picture, wow, this thing only happens every 9 years. And if it happens only 9 years, and 9 years ago when you wanted to watch it, it was cloudy, then this is pretty exciting to see. So, you're planning on not watching it for a while, and you're like, maybe I'll have time in the year 3085. I'm planning on living that long, so I really want to know if I have time in my schedule to see it on that day. Well, if it appeared in 2005 and it appears every 9 years, next year, put it in your calendars. Check out when that comet is coming through. This makes an arithmetic sequence because we are going up 9 every time. So method 1 that would work to solve this is we just keep writing years and see, do we hit 3085 or not? I hope you can see method 1 would be time consuming and possibly a little frustrating, because that's a lot of years to look forward. So since method 1, it would work, but doesn't seem like a very efficient method, then we start to look at, okay, maybe there's a way that we could use the formula. So what formula do we have so far? We go to our formula. We could either use the one that's given to us, in this case, or we could maybe use the one that works, but this one also, for the one that works, right? Remember, I would say it's going to be 9n plus something. Part of the problem with the one that works is these are big numbers. If I look at the first one, I would have 9. I would have to add 1,996 to it to make it work. Okay, so it's still the what works for formula would work in this case, but maybe the number makes you feel like, ooh, I don't know if I want to use that. If we use the formula from your formula sheet, and notice on the green paper, and some of you just got here, so I have a few more formula sheets for those of you that just got here. And we're on page 6. So if you use the formula, we know what term 1 is. It's 2005. We know that D is 9. So we can plug in the things that we know into our formula. And when it asks, is there a comet that appears in 3085? Okay? We are really asking, is 3085 a term in this sequence? That's our question. Yes, because you buy and then you write all your notes in there and stuff like that. Yes. So that's what we're asking. Is it a term in the sequence? Well, if it's a term in the sequence, then there is some number n that's equal, that makes that work. So the way that we can check it is we can use our formula. We can plug in 3085 for a specific term, even though we don't know what n is, and we can solve for n. If we solve for n and it works out to a nice number, like it's the 102nd term, perfect. We say yes, it will appear in 3085. If we solve for n and we get 102.3, not a whole number, that would mean that it's appearing somewhere in the middle and not a perfect term, then we would say it is not going to appear in 3085. So we set things up with our formula. I'll just put a question mark here because we don't know if that'll work. We'll plug it in. 3085 equals 2005 plus, and I'm going to distribute the 9 to give me 9n minus 9. If I solve an equation, we want to solve for n. Do you see that you would like to get the 9n by itself? We're going to move the 2005 over. We're going to move the 9 over. So 3085, I'm going to subtract 2005. I'm going to add 9. And I get 1089 equals 9n. Divide both sides by 9. And n works out to a perfect whole number. So the question was, if we reread the question, this is a skill that you'll need for math class. Determine whether the comet should appear. Yes, it should appear in 3085. If we got an answer that was a decimal, then we would say it doesn't fit perfectly with the sequence, and we would say that it shouldn't appear. Okay, again, at the top, once we're done a question, at the top, I will tell you a number from the practice. So above question number 4 or beside, you can write number 14. Then turn to the questions in the homework and circle number 14. Okay? I'm going to give you a little bit of time right now to try some of those questions, and I'm going to walk around and see if anybody has any questions so far in the stuff that we've been doing.